Look up at the night sky. Our Earth is one planet among hundreds of billions of galaxies. Just how big is the universe? It is bigger than anything we can imagine. Our journey begins on a planet that feels enormous to us. Earth is only one of 8 major planets orbiting the Sun. Beyond Neptune lies the distant Kuiper Belt. At the center of our solar system is the Sun, a star so enormous that Earth looks tiny beside it. The Sun is about 109 times wider than Earth, while our planet sits nearly 150 million kilometers away. By volume, roughly 1.3 million Earths could fit inside the Sun. And the Sun doesn't just dominate in size. It contains about 99.8% of the solar system's total mass. Earth is 1 astronomical unit from the Sun, but Neptune orbits roughly 30 astronomical units away. And when we finally see our entire solar system from far away, it becomes just a tiny neighborhood inside the Milky Way. Now we leave the solar system behind and enter something vastly larger, our home galaxy, the Milky Way. The Milky Way is more than 100,000 light-years across and contains at least 100 billion stars. And our solar system isn't near the center. We live roughly 26,000 light-years from the Milky Way's core. At the heart of the Milky Way lies a crowded galactic center, containing a supermassive black hole surrounded by enormous numbers of stars. Our solar system also moves around the Milky Way, taking roughly 240 million years to complete one orbit. But the Milky Way is not the universe. It is only one galaxy inside a much larger cosmic neighborhood. Our Milky Way belongs to the Local Group, a collection of more than 50 galaxies bound together by gravity. One of our closest major neighbors is Andromeda. It is located about 2.5 million light-years from the Milky Way. But galaxies rarely exist completely alone. Gravity gathers them into groups, clusters, and enormous structures. Some galaxy clusters contain hundreds or even thousands of galaxies, all interacting through gravity. Zoom out even farther, and galaxies begin forming something extraordinary, a vast cosmic web of filaments separated by enormous empty regions. And this is where the universe starts, becoming almost impossible to visualize, because these structures stretch across billions of light-years. Now we reach one of the biggest scales we can meaningfully describe, the observable universe, roughly 93 billion light-years across. But observable does not mean the entire universe. It means the region of space whose light has had enough time to reach us. When we look deeper into space, we are also looking further back in time, because light needs time to travel across the universe. The farther away a galaxy is, the older the light reaching our telescopes can be, allowing us to see the universe as it existed billions of years ago. And even this enormous observable region contains an astonishing number of galaxies, each potentially holding billions of stars. And beyond this observable horizon, we simply don't know what the full universe looks like. The visible universe may be only a fraction of everything that exists. So how many galaxies are out there? Estimates vary, but the observable universe may contain hundreds of billions, with some suggesting 2 trillion. And every galaxy can contain billions of stars, with some of the largest holding hundreds of billions or more. Our Sun is just one star, among at least 100 billion stars in the Milky Way.
Now multiply billions of stars by hundreds of billions of galaxies, and the scale becomes almost impossible to comprehend.
Depending on the assumptions used, estimates for the number of stars in the observable universe can reach roughly 10 sextillion to 1 septillion.
And remember, these staggering numbers describe only what we can observe, not necessarily everything that exists.
Stars come in an enormous range of sizes, temperatures, and lifetimes, from relatively small stars to giants hundreds of times wider than our Sun. Some stars are so enormous that our Sun would look tiny beside them, while others are far smaller. And stars are not necessarily alone. Astronomers have discovered thousands of planets, orbiting stars beyond our solar system.
Some of these worlds are giant gas planets, while others are small rocky planets closer to Earth in size.
Some planets orbit within regions where temperatures could potentially allow liquid water, but habitability is far more complicated than distance alone. So even a planetary system that seems extraordinary to us may be just one tiny system among an almost unimaginable cosmic population. And there is something even stranger about the universe. Space itself is expanding. It is not simply that galaxies are flying away from one central point. The space between large-scale structures is expanding. The farther we look across the cosmos, the more clearly we see this large-scale expansion. When we look across enormous distances, we are also seeing different chapters in the universe's history. The deeper we look into space, the further back in cosmic history we see, allowing telescopes to study how galaxies changed over time. And as we move toward the largest scales, one question becomes impossible to ignore. How far does this universe actually go? The observable universe is roughly 93 billion light-years across, but that does not necessarily mean the entire universe ends there. The observable universe has a horizon, but it is not a wall or physical edge that we could simply reach. We can observe this enormous region because light from distant objects has been traveling toward us for billions of years. Because space has been expanding while that ancient light traveled, the present-day distance to those regions can be far greater than the light travel time alone suggests. And beyond the observable universe, there may be vastly more space and galaxies that light has simply never had time to reach us from. So the universe we can see may be only a tiny part of the whole story. And that unknown is what makes the cosmos even more extraordinary.
On the largest scales, galaxies are not randomly scattered. They form an enormous cosmic web of connected structures.
These filaments can stretch across enormous distances, linking dense regions of galaxies across the universe. Between these structures are gigantic cosmic voids, regions where galaxies are far less common. Together, these filaments and voids create one of the largest structures known in the universe, the cosmic web. Between these structures are gigantic cosmic voids, regions where galaxies are far less common. Together, these filaments and voids create one of the largest structures known in the universe, the cosmic web. From Earth to the solar system, from the Milky Way to the cosmic web, every step reveals a scale beyond the one before it. And after traveling across these unimaginable distances, we eventually return to the place where our journey began, one tiny planet called Earth. From our tiny planet to structures spanning billions of light years, the universe defeats every sense of scale we have. The observable universe alone spans roughly 93 billion light-years across, yet we still cannot see beyond its cosmic horizon. And because the universe may extend far beyond what we can observe, its true total size remains unknown. Somewhere inside all this unimaginable space is one ordinary galaxy, one ordinary star, and one small planet where we exist.
After seeing the universe at its largest scales, Earth suddenly looks incredibly small. But it is the only home we know.
We may never know the full size of the universe. But one thing is certain: the farther we look, the more there is to discover. If you enjoyed this journey through the universe, subscribe and join us for more amazing space discoveries.